Yes, before we begin, can I please get confirmation that you guys can see my screen as well as hear me? My camera is not working today and it's causing a bunch of technical issues, which is mainly why we are so late today. So I apologize for that, but if you guys can hear me and see my screen, I don't think you can see my screen, so let me try resharing it. Just confirm with me, please. Can you guys see my screen or not? Anyone? Screen? No? Okay, there we go. I think it's sharing properly now. Perfect. Okay, cool. So, Assalamu alaikum and good morning, guys. Welcome back to grade 8 mathematics by Inspired Teens, where in today's lesson, we're going to be continuing fractions, decimals, and percentages, which is the last topic for the term. Okay. So let me just get out my notes. So last time, let's just do a bit of revision of what we did last time, and we can continue. So we started off this topic, okay? We're discussing fractions, where we looked at some terminology. We said that that's what a fraction looks like, a proper fraction. And we have the number on top as the numerator and the number at the bottom as the denominator. A fraction is sort of like a division symbol, right? So your division symbol represents a fraction. You have a number on top and a number at the bottom, okay? And you're dividing them by one another. So that's what a fraction represents, where the top is the numerator and the bottom is the denominator. And when the numerator is smaller than the denominator, we call that a proper fraction. And when the numerator is bigger than the denominator, we call that an improper fraction. Okay, then we have something called a mixed number, which is a whole number with a fraction. Example, 1 1/3, which means 1 whole and 1/3. So if we looked at the example in terms of pizzas, we said that we have 1 whole, okay, 1 whole pizza and then 1/3 of a pizza. So it's above 1. Okay, so that's what we call a mixed number. Undefined is when 0 is in the denominator or when you're dividing by 0. Okay, again, we discussed like 1 whole pizza. We can slice it into different, in this case, quarters. So 1 quarter, 2 quarters. Okay, anything we can segregate or separate into fractions, into different sized fractions. Okay, that's all we discussed. Okay, so let's talk about equivalent fractions. This is something I need to mention. Okay, now let's talk about equivalent fractions. These are fractions which have the same value but look different. They are found by either multiplying or dividing both the numerator and the denominator by the same number. Okay, so let's look at this example where we divide by the same number and we multiply by the same number. Okay, so in the first one we multiply by the same number. So how do you multiply fractions? I don't know if we're still getting there, but I'll just tell you now. You multiply fractions basically in a straight line, meaning numerator by numerator, denominator by denominator. Okay, so 3 times 2 is 6. And 4 times 2 is 8. So essentially telling us is that 3 over 4 is equal to 6 over 8. Okay, so the same ratio is maintained. How do we know the same ratio is maintained? Is because whatever we did to the numerator, sorry, whatever we did to the denominator, we did the same thing to the numerator, and therefore we got a fraction that has the same ratio, okay, as 3/4, which is 6/8. Similarly, when we divide, so if I say 12 divided by 3, I'm getting 4, 15 divided by 3 is 5, and that is basically saying that 12/5 is equal to 5/4. It's the same thing, because if I had to simplify 12/15, I could divide them both by 3, and I'd get 4/5. Okay, so these are exactly the same thing. They are equal, so they just have different numbers. Okay, so let's have a look here. Okay, so there are two ways of doing this, two ways of solving this. The first way is to identify what was done to either the top or the bottom. So obviously here the numerator is unknown, so we can ask ourselves what operation was applied to the denominator from 4 to get to 16. Okay, so then we can tell, oh, okay, 4 was multiplied by 4 to get to 16. So multiplied by 4 to get to 16. So what we do to the bottom, we should do to the top if you want to keep it equal, because there's an equal to sign. So it's saying that 1/4 is equal to what over 16. So if you want to maintain that equal sign, we have to do the same thing with whatever we do to the bottom, we have to do to the top. So we will do the same thing to the top. You get 1 times 4, which is 4. So your answer is 1/4 is equal to 4/16. Let's have a look at this example. So you can do the same thing. In this case, the denominator is unknown. So you have to see what did you do to the, what operation was applied to the numerator. In this case, from 10 to 5, we can see that we had to divide by 2. Okay, actually, technically, we should work the other way around, but it doesn't really matter. It doesn't matter. Because our unknown is actually on the left side, we should see how did we go from the left to the right. We multiplied by 2. So to go from there to there, we have to multiply by 2 as well. Okay, so to go from 5 to 10, we multiplied by 2. So to go from 8 to whatever's unknown, we multiply by 2 as well, and that becomes 16. So 10/16 is equal to 5/8. So there's one more way of solving these, and it's probably a bit more efficient, especially when the numbers become more difficult. So I'm going to express my unknown as x over 16. Okay, and similarly here, I'm going to say 10/x, which is the unknown, is equal to 5/8. Okay, so what you can do here is when you have two fractions equal to each other, you can do what we call cross multiplication, where you cross multiply them. So you multiply 1 in 16 and 4 in x. So 4 in x is 4x, and 1 times 16 is 16. You divide both sides by 4, and you get x is equal to 16/4, which is basically 4. So that unknown here, you solved for it now as 4. So like I said, this method is probably a bit more efficient, just because when the examples get harder and you're not able to tell exactly what multiplication or division was done to a particular term, it would it would then be easier. Okay, let's look at the next one. We have 10/x is equal to 5/8. Let's move this up. 10/x is equal to 5/8. Again, I can cross multiply. So I'm going to multiply bottom left, top right. Top left, bottom right. So 5x. 5 times x is 5x. 10 times 80. Okay, which is actually just 800. Divide both sides by 5. X is equal to 200. Yep, that is completely wrong. 5x is 80, not 800, sorry. Divide both sides by 5. 80 divided by 5 is 16. Okay, cool. So that's it, right? So there's two methods of solving equivalent fractions. Let's move on. Let's do changing mixed numbers into improper fractions. Okay, so going from a mixed number to improper fractions. So step number 1 says multiplying the whole number by the denominator add the numerator right over the denominator. When they say the, I want to add the same denominator. You need to keep the denominator the same and keep the original sign. So if it's positive, it's positive. It's negative, it's negative. So first step, multiply the whole number by the denominator. So you're going to say 1 times 4. Add the numerator, okay, 3. 1 times 4, multiply. So you're saying times 4, or even, yeah, times and add. So 1 times 4 plus 3. Let's use words. Multiply and add. Okay, and then keep the denominator the same. So 1 times 4 is 4, plus 3 is actually 7. So it becomes 7 as your new numerator. That's how you form it. So how do you, this, by the way, step 1 and 2 forms new numerator. Okay, so it becomes 7 and you keep the denominator the same over 4. Let's do this example. So this is multiply, this is add. So you're going to say 2 times 5 plus 4. You can write it out if you want, you don't have to. 2 times 5 plus 4, okay, over the same denominator, which is 5. So it's 10 plus 4, which is 14 over 5. Okay, let's do this next to multiply and add. So you can say 2 times negative 1 plus 1 divided by, or the numerator stays as 2. This becomes minus 2 plus 1, which is minus 1 over 2. No, that's wrong. Okay, so what you need to do actually is ignore the sign. You need not consider the sign. Okay, so you ignore the sign and just put it beforehand in the final part. So basically what I mean by that is you're going to say 1 times 2, okay, plus 1 divided by 2, and you just keep a negative before the fraction. So it's negative 1 times 2 is 2 plus 1 is 3 over 2. So you just keep that negative there. Keep the negative sign the same. Okay. Hope that makes sense. Everything's cool, up and running. Perfect. Let's look at the last one. So ignore the sign for now. Multiply and add. So keep the sign in front. And you're going to say 3 times 4 plus 1 over the same denominator, which is 4. You're going to have negative 3 times 4 is 12, plus 1 is 13. You're going to have negative 13 over 4. Okay, so that's how you go from a mixed number to an improper fraction. What about if I wanted to go from an improper to a mixed number? It would work similarly because what you do is, okay, you do the inverse of everything you did. So let's look at an improper fraction. Let's look at 11 over 3. Okay, so in this case, what you need to do, remember there we multiplied and we added. So here you're going to just divide actually. You're going to divide. Actually, 11 divided by 3. Okay, and 11 divided by 3 okay? Doesn't go in exact amount of times, but you basically ask yourself, how many times does 3 go into 11? How many times does 3 go into 11? 3 goes into 11 3 times with a remainder of, so you're going to say how many times does 3 go into 11? And what is the remainder? Okay, so your answer then becomes basically how many times does 3 go into 11? What can we call that? We can call it the quotient. Remember, the quotient is the answer to a division. So when you divide, when you say 11 divided by 3, you're going to get an answer of 3. So your answer is always the quotient, right? And then your remainder, then you create your fraction because it's a mixed number. And it's always your remainder, okay, over the same denominator. The remainder over the same denominator. Okay, so that's how you're going to structure your answer. For a mixed number. Okay, so in this case, we ask ourselves what, so the quotient again is how many times basically does 3 go into 11? Okay, the quotient is an answer to a division. So when you say 11 divided by 3, you're going to get 3 remainder, whatever. So we ask ourselves a question, how many times does 11 go into 3? That would be the answer to the quotient. 11 goes into 3 times with a remainder of 2 and keep the denominator the same. So 11 over 3 can be written as 3 and 2 over 3. 3 and 2/3. Let's do one more example. (15 over 4). Right? How do we form our answer? It's, remember, the whole number is the quotient. And you basically say you divide, and then your remainder, essentially. Right? Remainder over the same denominator. So in this case, my quotient, I ask myself, how many times does 4 go into 15? I say 15 divided by 4. I get an answer of 3 times with a remainder of, because how do you calculate the remainder? You can say 4 times 3 is 12. And then 15 minus 12 is 3. With a remainder of 3, same denominator, over 4. Okay, so that's how you'd go from improper to mixed. Let's talk about, very importantly, adding and subtracting fractions, and we'll learn multiplying and dividing fractions. Very, very important. Please pay careful attention. This is crucial. So it's easy, okay, but many people forget it for some reason, especially when you get to higher grades, and then people totally forget about it. The steps: convert mixed numbers to improper fractions. Okay, so we don't want any mixed numbers. We only want proper fractions or improper fractions. That's it. Find the LCD. This is the most important thing. Whenever you are adding or subtracting fractions, that is the most important thing. Finding the lowest common denominator. That's how you end up adding them, by finding the lowest common denominator. Number 3, you need to add or subtract the numerators. Remember to use BODMAS. Okay, we'll go through that. Simplify if possible. Do not convert back to mixed numbers. So just keep it as an improper fraction if the answer is an improper fraction. Let's have a look at this. Okay, so whenever we have fractions with the same denominator, there's no need to do LCD, lowest common denominator, because the denominators are already the same. So you can write this all under one denominator, and then you just add the numerators. Okay, I hope that makes sense. So you can just write them all under one denominator and add the numerators, and you'll get 3/4. Let's look at this one now, though. So this one, I can't just say this is equal to 2/8. Yeah, please don't do this. Please do not do this. Do not add them in a straight line. The only ones you do in a straight line are when you're multiplying. If this is multiply, you do it in a straight line. Adding and subtracting, you have to do LCD. You have to do LCD. Here, the LCD is already done because they already have a common denominator. Okay. Here they don't have a common denominator. The LCD needs to be established, and then we can simplify. So when we talk about LCD, this is lowest common denominator. Okay. And lowest common denominator is essentially the same thing as lowest common multiple. And multiple is basically your timetables. So if you have to talk about the multiples of one, okay, not one. You have to talk about the multiples of 7, you'd say 7, 14, 21, multiplying 7 by natural numbers, 1, 2, 3, 4, 5. So 7 times 1, 7 times 2, that's multiples, right? Remember, factors are numbers that can go into other numbers an exact amount of time. So factors are different to multiples. Multiples is basically when you multiply that number that you have by 1, 2, 3, 4, 5, 6. Factors are when you find all the numbers that go exactly into that number that you're working with. So lowest common multiple. Does anyone know? Can anyone tell me what's the lowest common multiple between 2 and 6? The LCD between 2 and 6. Anybody? No one? LCD between 2 and 6? 6. Okay, so there's like numerous ways of doing it. If there are small numbers, many of the times you can guess what is the lowest common multiple between the two. You could do LCD, which could be very unnecessary. Okay, remember we learned how to do lowest common denominator using factor method, or what is it called? Tree diagram thing, stem and leaf. And we wrote things as the product of their prime factors, and we got LCD. But these are small numbers that'd be ridiculous. If you're really stuck, you could write them out. So 2, 4, 6, 8. These are the multiples of 2. 1 times 2, 2 times 2, 3 times 2, 4 times 2. And you can do the same thing for 6. Multiples of 6. So 6, 12, 18, 24. And you're going to find the number in this list that is common and is smallest. The smallest numbers that are common, and you can see that it's 6. Okay. So I write this over 6 plus that over 6. Now, we got our new denominator, which means we changed the old new denominator. So we have to ask ourselves the question, how did we get from the old denominator to the new denominator? Yeah, we had to multiply by 3. Okay, so what you do to the bottom, you do to the top. So when you do that to the top, 1 times 3 is 3. Okay, then we ask ourselves the question, how did we get from this denominator to that denominator? It's the same thing. So you multiply it by 1 basically. So you multiply the top by 1 as well, you're left with 1. Now they have like bases. Since they have like bases, I can simply write them under 1 base and add the numerators, which is 4 over 6, which could be simplified to 2 over 3. Okay, so that's how we add with lowest common denominator. Let's have a look at this example. Somebody tell me between 8, 4, and 2, What is the lowest common denominator? Okay, someone says 2, someone says 8. So 2, let's consider, okay, so we're going to do this for the first few. We're just going to write them out until we get the hang of it. 2, 4, 6, 8, 10, and so on. These are the multiples of 2. Okay, remember multiples, guys, multiples. Okay. Multiples of 4, 4, 8, 12, 16, and so on. Multiples of 8, 8, 16, 24, and so on. Now, somebody says 2. Okay, if we look at 2, right? If we look at 2, okay, 2 is not a factor in 4 and 8. 2 is not a factor of 4 and 8. 2 is too small to be a factor of 4 and 8. Remember, factors are like 1 times that number, 2 times that number, 3 times that number. So the first factor of 8 is 8. It's way bigger than 2. So it cannot be 2. Right? Then we look and we see 8. 8 is here, 8 is here, 8 is here. This is the lowest common factor. Okay, so it would be 8. Do you have to simplify the fractions? Yes, you should definitely. If you're allowed calculators, just put your final answer in the calculator. It will give you the simplified version. Alternatively, you have to find a number to divide both 4 and 6 by. If it's an even number, you can do 2 and 2 and 2 until you get it to its simplest form. So here I'm going to change. This is what I do. I change all my denominators to 8. Over 8 plus over 8 plus. Now let's look at what changes were made. To get from 8 to 8, nothing. It's like times by 1. So I times 1 by 1, I'm left with 1. Okay. How did I get from 4 to 8 though? That had to be multiplied by 2. So what I do to the bottom, I do to the top. 1 times 2 is 2. How do I get from 2 to 8? I multiply by 4. What I do to the bottom, I do to the top. I get 4 over 8. So now I have all the same denominator. You can even write it now under one denominator. You can say 1 plus 2 minus 4. Times the same, numbers the same under one denominator. 1 plus 2 is 3, minus 4 is minus 1. So it becomes minus 1 over 8. Is that correct? Yes, correct. Let's discuss multiplying fractions. If there are no questions, why do we have to change the numerator? So you have to change the numerator because you cannot change the ratio of the fraction. Meaning here, the ratio is saying 1 over 8. So for every 1 part here in the numerator, we have 8 parts in the denominator. So if I had 2 parts in the numerator, that would result in having 16 parts in the denominator. Okay, so you don't want to change that ratio. So like, then if I had to make it 3, 16 would have changed to 24. So for every 1, it's giving me 8 basically. So if I have something like 2 over 5, for every 2, it's going to give me 5. So if I make it 4, it's going to become 10. If I make it 6, it's going to become 15. Okay, so for every 2, you're getting 5. Okay, so you have to maintain that ratio, because if I have to look at 2 over 6, and then 3/5. This is completely not true. Because how do I go from 2 to 3? I have to multiply by like 2/3. Then that's not the same to get from 6 to 5. This is completely incorrect. Okay. So yes, this is completely not true. So we want to avoid that. We cannot have 2/6, for example, is equal to 3/5. That's not equal. So we cannot change the value of the fraction. And you see here, we want to add fractions, right? We want to add 1/8 plus 1/4 plus 1/2. Then what's the point if I had to just say like 1/8 plus 1/1, like, if I could just change anything the way I wanted to. So if I wanted to say 1/8, and then I'm going to say, I'm going to change 1/4 to 1/8. And then I'm going to change 1/2 to 1/8. It doesn't make sense, right? Because now I've changed the value of them completely, entirely. So then that's why, what's the point of doing this calculation? Okay, so you're keeping it the same because firstly, you want to do your addition. You want to add these fractions with different denominators. However, you cannot add them with different denominators, okay, because they're different fractions, right? So what you got to do is you got to make them all the same denominator. You're going to make them all with the same base, okay? And in order to do that, you need to find a common base between those numbers. So a common number between 8, 4, and 2, not just a common number, a common multiple between 8, 4, and 2. Okay, so yes, that's why we have to always, so we're changing the denominators to the same denominators so that we can complete the addition and subtraction. Okay, but so when we change the denominator, okay, we have to change the numerator as well. So that's why you always consider, how did I get from this denominator to that denominator? If I do whatever I do to the bottom, I do to the top as well, to keep it the same. So here, when I have 1/4 and 2/8, these two are equal in value. I have not changed the value of the question. I'm not changing the question. 1/4, this is equal to 2/8. When I change numerator and denominator and multiply, when I change both denominator and numerator, right, and multiply them by the same number, these are equal in value. So 1/4 is equal to 2/8. You can even prove it if you have pizza, right? If you have a quarter, okay, and if you have, let's just copy this. If I separate it further, okay, you can see that when I represent 1/4, so this here is 4s. It's like 4 out of 4 slices, and here is 8 out of 8. So there's 8 slices, okay? So if I want to represent this part, that part, this would be 1 out of the 4. Now the equivalent of that is this. Okay, they're the same size. This and this, they're the same size. And this is actually 2 out of the 8. Why don't we just add all 3 ones instead of multiplying the numerators? So you cannot add if they have different denominators. So if you have 1/12 plus, well, let's do 1/6 plus 1/5, 1/4 plus 1/3. I can't. So again, you cannot add, like, for example, if you're going to say 1 plus 1 plus 1 is 3, 6 plus 4 plus 3 is 13. This is totally incorrect. If you have to check it, like diagrammatically, if you have to check it, if it's true with a diagram and with pizzas, it would be completely off. You cannot add, that's a rule. If they have different denominators, you cannot add the numerators. You need to get them all to the same denominator. When you get them all to the same denominator, that's when you can add them. So the method in which to get them to the same denominator is to find the lowest common multiple between all of them and make that denominator the same across. So what's the lowest common denominator between 6, 4, and 3? So again, we are looking at multiples of 3. So yes, to answer your question, basically you cannot. That's a rule to say that you cannot add fractions that do not have the same denominator. You'd have to make them, their denominators the same first, then you can add them. What's the LCD, the lowest common? Someone tell me, what's the LCD between 6, 4, and 3? No problem. Anyone? Lowest common denominator between 6, 4, and 3. Lowest common multiple is 12. Correct. So lowest common denominator, lowest common multiple, both the same thing. So we have 12, right? There's many ways you can do it. You can do it. Again, at this point, I feel like you guys should need to get used to these numbers. Like 6, 4, and 3 are numbers that you should immediately know, okay, they meet at 12. The first quickest place they meet at is 12. Because you sometimes you want to try the biggest number always. So then you'll say, oh, let me try 6. 3 can go into 6, but 4 can't go into 6. Okay, so you could use like your making it the product of its prime factors. That method would be long. You could write out maybe for smaller numbers, what's the quickest way if you're stuck, is to write out each multiple. For the multiples of 4, you write the first 5. Multiples of 3, you write the first 5. Multiples of 6, you write the first 5 and see if there's any lowest common multiple there. So yes, it is indeed 12. So I make them all 12. So now when I make them all 12, you see I'm doing this, I'm making them all 12 so that I can add them, because the rule says that you can't add unless they're the same bases. But now I can't just make them 12. I need to keep the value the same. So what I do to the denominator to get it to 12, I need to do to the numerator so to keep the fraction equal so that 1/6 hasn't changed. I want to change the denominators, but I don't want to change the value of the fraction as a whole. So 6, how did I get from 6 to 12? I had to multiply by 2. So I will multiply the numerator by 2 as well, and this becomes 2/12. How did I get from 4 to 12? I had to multiply by 3. So I multiply by the top by 3 as well. It becomes 3. How did I get from 3 to 12? I multiplied by 4. So I'll multiply the top as well. Okay. Now they have the same denominator. So I can add them. So I can literally keep them all under the same denominator and say 2 plus 3 plus 4. And that's equal to 9/12. Okay, and 9/12 can actually be simplified even more because you can divide them both by 3. Again, you can put this in your calculator. It'll give you the simplest answer, or you can find a number that goes into both numerator and denominator, and that would be 3. This becomes 3/4. Okay. Adding and subtracting. Let's talk about multiplying fractions. So multiplying fractions, the step is to simply cross cancel top with bottom, multiply numerators, multiply denominators, simplify. Okay. So you see the thing with multiplication, right, is you can replace all of this with just the fact that you need to just multiply in a straight line. Okay, so you're multiplying in a straight line. So basically you're saying 1 times 4 and 8 times 7. Okay, before you multiply, however, you can attempt to simplify, right? Anything, this is key, top with bottom. Anything at the top and anything at the bottom that you can simplify, you should try and simplify. So if they are divisible by the same term, or if they are divisible by the same number, that's when you could simplify them. For example, so anything on the top, by the way, it doesn't have to be on top of one fraction and at the bottom of that same fraction. I could try and simplify 1 and 7 or 4 and 8. Okay, maybe let's leave it out for now, and in the next one we'll do it. No, okay, we'll have to do it now, unfortunately, because there's no other example. I suppose I can always just add my own example. So let's do that. I'm just going to multiply in a straight line. That's it. So when it comes to multiplication, you can do this, but addition and subtraction, that's a bit more complicated. You have to do LCD. Okay, you have to. There's no choice. You have to. Okay, but with multiplication of fractions, you can just multiply in a straight line. It's easy. So 1 times 4 is 4, and 8 times 7 is actually, I don't even know, 56, I think. Okay, so now you can simplify further. So if 4 can go into 56, you can divide both by 4, and it would simplify. Alternatively, you can put in your calculator if you are allowed to, and it will give you the simplest form. 4 goes into 4 once, and 4 goes into 56 14 times. So this simplifies to 1 over 14. Let's do okay, let's have a look at this example. Okay, so again, same thing. You can do the same thing to multiply in a straight line, numerator by numerator, denominator by denominator. However, you can make your life a bit easier by simplifying before you do the multiplication. So like I said, you can simplify a term on top and a term at the bottom, wherever they are. So even if they are in two different terms, for example, 3 and 11, if I could simplify it, I can simplify it. Let's look at 8 and 16. How can I simplify 8 and 16? Okay. Basically, I can divide both of those numbers by 8. So when I divide 8 by 8, I get 1. When I divide 16 by 8, I get 2. So 16, 8 get simplified to 1 and 2. Okay, nothing else can be simplified. So this can become 3 times 1, which is 3, and 2 times 11, which is 22. Okay, so now let's do another example. Let's do 14 over. Okay, yeah, sure. Let's just do this. 28. So 6 over 14 times 28 over 9. So remember I said it doesn't, you don't have to cross simplify. You could simplify from top to bottom. For example, 6 and 14. I know that I can divide both of those by 2. When I divide 6 by 2, I get 3. When I divide 14 by 2, I get 7. Okay, so it doesn't have to just be top left, bottom right, top left, bottom right, or bottom left, top right. Could be a fraction itself, which you could simplify, 3 over 7. And I can simplify even further. For example, I know that 7 and 28 I can sort out because I can divide 7 by 7 and I get 1. And I can divide 28 by 7 and I get 4. Then with 3 and 9, okay, 3 goes into 3 one time, but 3 goes into 9 3 times. So I've simplified. So this here is 1 over 1, by the way. And without me doing any calculations, I'm left off with 4 over 3. And that's the most simplified version. Okay. That should be fine. I don't think we need to do more examples. Let's have a look at this. We have 2 times 3 over 16. Is there class next week? Yes, there's class every week. Whether it's holidays, fasting month, snowing, whatever, we will have class. So if you can't make it, you can always watch it later on YouTube. Okay. So when you have a non-fraction, which is just 2, multiplied by a fraction, what do? Really simple. You take the non-fraction and you make it into a fraction by dividing it by 1. Any non-fraction you can turn into a fraction by dividing by 1. So you say 2 over 1 times 3 over 16. And now you do the same thing. So I'm going to multiply in a straight line. However, I do notice that 2 and 16 I can simplify. 2 goes into 2 once, 2 goes into 16 8 times, and done. That's 1 over 1. So it's just going to multiply by 1. So this just becomes 3 over 8. Let's look at this. So this involves multiple things. Okay. Firstly, we need to convert 3 1/4 to a whole number. So we can multiply and add. Sorry, not a whole number. We need to convert this mixed number to an improper fraction. We can multiply and add. So 3 times 4 is 12 plus 1 is 13. Keep the same denominator of 4 times 3 over 26 times 1 over 9. Honestly, it doesn't look like we can simplify anything, yeah? Actually, we can. 13 and 26, because 13 goes into 26. So 13 divided by 13 is 1. 13 divided by 26 is 2. So now let's multiply in a straight line. 1 times 3, 3 times 1. 1 times 3 times 1 over 4 times 2 times 9, which is equal to 3 over 8 times 9. Let's check. Something isn't right. No, I think it's right. Never mind. We can just simplify this even more. So you can just put in your calculator again, and it will give you the simplified answer. Alternatively, you need to find a number that goes into both, and that number is 23. 3 goes into 3, and 3 goes into 72. You could also have simplified it a bit more here with 3 and 9, but I didn't, and we still got the same answer. The more you simplify, the easier it's going to make it on you, basically. Okay, since we did start late, let's end a bit late. So let's finish the dividing fractions. So how do you divide fractions? You don't. You just tip and times. So you keep the first one the same. Okay, so you keep the first fraction the same and you tip the second one and obviously tip and then multiply. So 1 over 2 divided by 1 over 3, it becomes 1 over 2 times 3 over 1. That's what happens. Multiply in a straight line, you get 1 times 3, 2 times 1, which is 3 over 2. Let's move on to the next one. 1 over 4 divided by 1 and 1 over 16. So you're going to convert it to an improper fraction first. So multiply and then add. So this is basically like saying 1 over 4 times. Okay, let's divide first, convert it to the improper fraction first. So 1 times 16 plus 1 is 17. This becomes 17 over 16. How do we divide? We don't divide. We say 1 over 4 times 16 over 17. I can simplify it to make my life easier. 4 goes into 4 one time. 4 goes into 16 4 times. Becomes 4/17. Okay, so let's move on to the next one. What if we have 1/3 divided by 2/7 divided by 21/8? So in this case, we're going to take it one at a time. So remember BODMAS, right? BODMAS says that whenever you have only division or only multiplication or only addition or only subtraction, you basically got to do it in the order that you received it. Okay, so I'm going to do this one first. 1/3 divided by 2/7. This is going to become 1/3 times 7/2. Tip and times. So now I can multiply in a straight line. There's nothing to simplify. It becomes 7/6. And I'm going to multiply it by the inverse of that, which is 8/21. Because it's originally divided, so you tip in times. Can we simplify? Yes, we can actually. 7 goes into 7 once, 7 goes into 21 3 times. 2 goes into 6 3 times, 2 goes into 4, so 2 goes into 8 4 times. So 1 times 4 is 4, 3 times 3 is 9. My final answer is 4/9. What about non-fractions divided by fractions? Same concept. So you have 12 divided by 1. What you're going to do is you're going to keep the first term the same, flip the second term, but we're going to express the first term as a fraction. So 12/1 times 2/1, because it was 1/2. So we flip it and it basically becomes 24. Please note, you cannot cancel in a straight line. You cannot cancel across. Okay. So if you had something like 5/4 times 25/6, you can't cancel this and say 5 goes there once and 5 goes there 5 times. This is incorrect. It has to be 1 on top, 1 at the bottom. Basically 1 in multiplication, 1 in division. What does tip mean? Tip or flip, whichever one you decide to use. Tip or flip. Some people just say flip. It basically means if your fraction is A/B, you need to make it B/A. You put the numerator in the denominator and the denominator in the numerator, like we were doing here for these examples. For example, here, where we said 1/3 times 7/2 divided by 21/8. You can't divide fractions, you multiply and then you tip it. So 8/21. I changed it from 21/8, multiplied it to 8/21. Okay, let's move on. Where are we? Yes, so in this case, right, non-fractions you write as fractions. Any non-fraction you can write as a fraction over 1, and you flip it. So instead of having divided by 1/2, you're going to flip it. You're going to say multiplied by 2/1. Then you just have 12 times 2, which is 24. Let's talk about the last and final example. 2/5 divided by 6. So 2/5 divided by 6, remember, you're going to make it 2/5 times, okay, no, let's divide. 2/5 divided by 6/1. You have to convert it to a fraction first, which is simply 6/1, okay? Thereafter, you need to tip and times. So you keep the first one the same, multiply, and then instead of having 6/1, you're going to have 1/6. And then you can simplify in a straight line. So 2 times 1, 5 times 6. 2 times 1 is 2. Or you can even simplify. So let's simplify. 2 goes into 2 1 time. 2 goes into 6 3 times. So I have now 1 times 1, which is 1. 5 times 3, which is 15. But yeah. Yes, you only tip the second fraction. Correct. You keep the first one the same and you tip the second fraction. That is indeed correct. But yeah, okay, so let's end it there. And when we come next time, we will continue with a lot of stuff, I guess, just still decimal fractions. So we have converting common fractions, decimals, percentages, common fraction to percentage, percentage to decimal and common fractions, square roots and cube roots, so fractions and decimals, decimal fractions adding, subtracting, multiplication, and division of decimals, and rounding off decimals. A whole bunch of decimals. But yeah, okay, cool. Let's call it there. Thank you guys so much for attending. I will see you guys next week, same time, same place. For those of you on holiday, enjoy it. For those of you still in school, all the best. And yeah, I'll see you guys next week, inshallah. Jazakallah khair. Thank you. Assalamu alaikum and goodbye.